You got it? All righty.
Keep wandering a little bit, but.
There's our water, foreign water. This year.
Yeah?
Yeah.
Good.
Tell them what you got.
They get signed?
I tweeted about this topic, hey guys. Guys, we're gonna start. Yeah, this is a huge issue. I tweeted about this. They're exploiting Tibet's supposed to be very pristine water. So this is a huge issue, and what the volume of water that they want to put into bottles is supposed to be huge as compared to what's already on the market. So people are joking about flooding the market with bottled water. There was another story about bottled water this week about how Aquafina and Dasani, which is Pepsi and Coca-Cola, that they really do use tap water in Aquafina and Dasani, and selling it at I don't remember what the amount was, like 1,000 or 2,000% higher than what the tap water value is. So making some serious money on that. So yeah, that's a great topic.
It's muted.
We have another one.
Good.
Yes.
What else?
Hold on.
So this isn't, I mean, it's international, but it's a little more than international.
Wanted to get beyond Texas.
So it talks about, like, if we were to harvest the water resources on Mars, theoretically, like, who would get to it, and it talked about prior appropriation and how that would kind of entice people to explore and try and get out there, and kind of talk about, like, the flaws with our current management on Earth, and maybe trying to use Mars's water might show, like, how we can better manage water. That's kind of what it talks about.
They say that
That's a great.
T-Boone Pickens has already made a tentative offer.
It's a great topic. I love that. If somebody wants to send me the link to that, I'd love to see that.
Oh, yeah.
Yeah, because international law only goes so far. I don't know. I mean, we have the international space law, but I don't know how this would apply to water.
Matt Damon talked a little bit about it in the Martian movie.
Oh, he does? Well, I haven't seen that.
It's very good. Yeah.
Wow. No, that's a
Yeah,
good.
the law of the
Yep.
sea.
That's a
Because he
great.
said if you're not in any country, then you are under the Treaty of the Sea, so he's a pirate. That's how he kind of like,
Interesting.
uh-huh.
Okay. Well, good. And any other topics? Anybody else found?
I found one, but I don't.
That's fine.
It's about Iran last year imported 10 billion agro products from other countries. So they're trying to move away from the oil and gas business and do more agriculture and manufacturing. And
Now you said they imported.
imported.
Okay.
So
What's the implication here?
because they don't have enough water for irrigation of their arid zones and everything. So they're bringing experts from Australia that have done great things with minimum amount of water to see how they can develop that and try to bring that into their area.
Yeah, the whole notion of importing, especially agricultural products, this is something that's called virtual trade, which is great timing because I actually have a couple things on virtual trade or virtual water. Virtual water is the water that's in commodities, and people have been trying to quantify the amount of water that it takes to produce agricultural products or even automobiles, everything. And if you don't have that water domestically, you're importing that water in the product. So places like Iran, which right now is suffering from a very serious drought, they're importing water. In a sense, they're becoming dependent on other countries for water to produce those products, which is can be strategically and from a security point of view can be an issue. On the other side, think about the countries that are exporting the products and thereby exporting the water. indirectly. They're not sending the water over, but they used all that water for the export market. And the numbers, this is a slide a little outdated, but I mean, the volume of water going through trade is huge.
Dr. Eckstein, the slides aren't
Yeah.
showing up in College Station.
I'm sorry?
The slides aren't showing up in College Station.
Okay, I don't know. Hold on, let me see something. Okay, now we're seeing Galveston. And Galveston, did you guys see my slides?
Yes.
Okay. So let me try to send them again. All right, are they on the screen?
No, they're not.
Yes, in Galveston.
Okay. College Station, if the tech guys are there, is it something?
Yes, they're talking to the
I'm calling the
support
support
staff.
desk.
Yes, they're calling the support desk right now.
Okay. All right, well, I will make sure to send these slides. I just had 2 slides. One of them is showing a big map of the world with numbers and arrows in terms of how much water is going from countries, from countries with water to countries without water. And it's just a tremendous, in the billions of cubic meters of water per year. So, for example, out of Brazil, and Brazil exports a lot of agricultural products, 49 billion cubic meters per year is going to Europe. Another 19.2 billion cubic meters of water is going to Asia. And that's inside the products, or in the that's the amount of water that it took to produce those products. So the point you made about Iran importing, this whole issue of virtual water is a huge issue, and I'm not sure there is any need for law on this, but it's certainly there's some policy implications here. One other slide I was going to show. There's a lot of value in virtual water. In terms of a country like Saudi Arabia, who used to grow their own wheat and alfalfa with very limited water resources. So what's the value of the water in Saudi Arabia for purposes of providing water for drinking versus growing alfalfa or hay or wheat, as opposed to buying the wheat or the alfalfa on the open market? It's going to be cheaper for them to buy it on the open market from the United States or Canada or other places that have more water availability, where the value of water is lower. And as a result, say overall global water savings in 2007, that's the last date I have it for, that was around 9%. 9% global water savings. That's a tremendous amount of water saved. And I'll make sure to post these 2 slides. But the reason why I brought up virtual water, in addition to what Awilda was talking about Iran, is because there was a great news story on NPR this morning. And the title is Saudi Hay Farm in Arizona Tests State's Supply of Groundwater. Saudi Arabia has bought land in Arizona and is growing hay and alfalfa to export back home. So what they couldn't grow in Saudi Arabia, they're actually doing this in Africa and apparently now in Arizona. And I heard at the very end of this news story, they're talking about they're also starting this in Imperial Valley now in California. They're buying land, growing these products, and then sending them back to Saudi Arabia. I suppose we can talk about the free market. This is great if you like the free market. The concern I have is Saudi Arabia is a desert country which decided at one point to grow hay and alfalfa and some other products, and then decided not to because of depletion of the groundwater and the other resources. Now they're going into Arizona, another desert. Imperial Valley, that's another desert.
For the cost of the land.
Why do they pick desert locations? Is there any
That I don't know.
circumstances that they talked about?
They asked the same question in this story on NPR, and they didn't answer it. They didn't interview the Saudis. It was a reporter who broke the story or found out about the story.
Is it like, was it the Saudi government or Saudi business or just the Saudi?
I think it's connected to the Saudi government. Many of the businesses in Saudi Arabia are connected to the Saudi government. So this is a national priority for them. They've bought out large blocks of land in Africa. By the way, China has done the same thing. They've bought large blocks of land in Africa, and they're now growing all sorts of agricultural products to export back into China.
Are we putting the value of the water that we're using when we export something into the price of that product?
What a great question. Think about it. Are we putting the value of the water into the product? That would mean the farmer would have to pay for the water, right? Does anybody know of a farmer that actually has to pay for his water? Municipalities. Those of you who have homes, you get rent apartments, you get water at the tap, and you pay a certain amount.
Texas, we have the rule of capture.
Texas, we have a rule of capture. You own the land, you own the groundwater, and you don't pay for it. Most other jurisdictions, including Arizona, which is a reasonable use groundwater state, it's similar to the rule of capture, as long as the use is reasonable. But you can use as much as you don't have too much of an impact on your neighbors. But there's no payment. Even for prior appropriation states, you might have to get a permit. So you pay for the permit, but that's a minimal amount in relation to the volume of water. So Saudi Arabia comes to the U.S. where we do not have any kind of regulations or prices on groundwater, which I think is pretty smart of them.
Yeah.
Not sure it's pretty smart of Arizona.
No.
Or California or anywhere else in the U.S. So really, if you check out NPR Morning Edition from today and just scroll down, you'll find this story. And it's, I think they don't have the transcription yet. I think they have it just summarized. Yeah, interview highlights. But you can certainly listen to the story on there. They've got the whole podcast on there. So, any other stories? Anything else in the news you guys found?
I know this isn't directly related to international water law, but have you read about the shade balls that they're pouring into aquifers to prevent evaporation and things like that? Have you read anything about that? I know that they dropped 96 million shade balls into an aquifer in Los Angeles, which I thought was pretty cool.
Okay, not in an aquifer, into a reservoir maybe.
Was it a reservoir? Oh, okay. Yeah, sorry.
Yeah. Do you know why they're doing this?
For evaporation and microbial
Exactly.
growth and things like that.
Yeah, there's a growing awareness, especially in the United States, but elsewhere around the world, that all these big open reservoirs that we have, especially in the arid parts of the country, they're evaporating, 10, 20% of the volume, just completely disappearing. And so they've been trying to come up with different technologies from around, literally around the world, coming up with ways of keeping the water to prevent it from evaporating. One of the ways is with these, little plastic balls, and it has to be, environmental friendly. It has, to all the critters out there, so they can't swallow them, or they can't harm them in another way. They can't biodegrade, especially in sunlight. That's a big problem with plastic. So these are special balls that apparently don't biodegrade very quickly. Antimicrobial, yeah. And you remove that open surface area, that evaporation, the sun would pull up all the water. They've tried to do this with oil.
So how would that not have an effect
What do you mean?
These plastic balls, how would these not have an effect? That seems like a really absurd idea to me as far as the ecosystems and any sort, I mean, is there like study that can affect the macroinvertebrates or the fish or anything?
They're studying this now. They know that the birds can still, get into the water and kind of swim in between them because they're very light plastic balls.
I mean,
Well, they're
but
filled
yeah, it's
with
very
water.
odd.
They're made of
What's that?
they're made of polyethylene, and they're filled with water so they won't blow away, and they're coated with like radiation resistant some sort of coating.
Right.
But
Yeah.
I don't think it says on here that one of the
There's a
main
project,
yeah, the NRDC hasn't responded to like if it's toxic or not. So that
Right.
I don't know.
well, not even like looking at the toxicity, but like when a dragonfly is a nymph and in the water, when it wants to come out of the water, can it get out or is it blocked?
These questions have not been really developed yet.
there is a project that has been funded by the Texas Water Development Board on Lake Arrowhead, evaluating those things in a monomolecular film that they put over the
I think I
water.
heard us save people a lot of money.
Yeah. Well, some of the other ideas that I've heard, one is oil substance or some kind of, I think you call it a monofilm, and they're trying to put on top of the water because oil floats on water, and it also can help prevent evaporation. The problem with that is the wind tends to blow the oil to one side or the other, and the other part is I don't know how the birds and other critters deal with the oil on top. But yeah, it's a huge problem. Evaporation.
There is a paper on the web. I have a student who's researching that just as we speak. And there is progress reports of the work at Lake Arrowhead about the monomolecular thing. And also a comment about the little plastic balls, whatever that she was talking about. I'll post that for you.
Yeah, that'd be great.
Yeah.
Good. Anything else? Any other stories? All right, and we're looking at a screen that's really darkened, so I don't know who we're seeing or not seeing, but it's.
That is us, and our camera is pointing to the ground. And so you will just have to hear us from out of a darkened room.
Okay.
Voice
All right, just
the bowels of the
wondering.
earth.
All right, just wondering. I also wanted to, if nobody has any other stories, any other news items? All right, let me, there's a book I started reading recently, and I have to say this is really a fantastic book. Now, maybe I'm biased because I am Israeli, but this is a book by an American lawyer and water expert. His name is Seth Siegel, and the name of the book is Let There Be Water, Israel's Solution for a Water-Starved World. And the book is really all about the technological developments that Israel has developed over the last 50, 60 years. So far, I'm about halfway through, and I really highly recommend it. It's all the drip irrigation and how they came about to develop drip irrigation, the desalination technology, water reuse. Water reuse in Israel right now is around 85% of all sewage water is being reused. It's a really fascinating study, and I'm going to see if I can try to bring him to campus because the book is fantastic. This just came out, I think, about a month or two ago. If you Google Let There Be Water, Seth Siegel, Siegel, really fantastic, interesting book. Now, for those of you interested in the Middle East and water issues, this does not address the political issues. So just be aware, this is solely about the technology and the methodology that's being developed and has been developed in Israel over the years, and really fantastic. But for those, because I've had some emails from some of you about water in the Middle East region. And one of my favorite books, which I think is about as unbiased as you can get for the region, Palestine and Israel, is this book called Water Wisdom. It's written collaboratively by Israelis and Palestinians, and what they've done is they've taken the various issues and they've written them just from their perspectives. And then there's a review of the two essays by both of the editors. So they're talking about even how to characterize the water, how to identify the water resources. And there's a difference from a Palestinian perspective versus an Israeli perspective. What are the important water resources? And how to characterize them in terms of the importance of water. Past water agreements, the water culture of Israelis and Palestinians, water legislation, groundwater management, drinking water standards, the Jordan River Basin, again, from an Israeli perspective and a Palestinian perspective, Gaza's water situation from the two perspectives. Really, I think one of the least biased compilations I've seen in a long time. So it's called Water Wisdom, really a fantastic book. So that's in response to a number of you who have been emailing me. And if you want any other recommendations for books, I'm happy to do that. All right, a couple of administrative things before we move on. First of all, hopefully everybody's received the information about the negotiation exercise. If you have not received two emails from me, one with the general, yes, we can see you, great, with the overall hypothetical fact pattern, hopefully everybody received that, and then I sent a second email with the confidential information for each team. If you haven't received two emails, please email me and let me know. We will be doing this negotiation exercise in 2 weeks. As I mentioned in here, the technology issue is going to be important because we're on 3 different campuses. You need to plan and strategize as soon as you can. Hopefully you figured that out when you were doing your case studies. As we're going to negotiate, texts and whatever other apps you can figure out to talk sort of behind the scenes will probably be helpful. Okay?
And then so we all get in here next time, or
Well, it's 2 weeks from today.
2 weeks from now, and then we have an hour and 50 minutes to come up with a plan?
I'm going to allocate about 80 to 90 minutes to try to work out.
So is there any channels for one group to talk with another group, or is it everybody, all 4 groups, just a...
There is no communications, well, let me put it this way. That's an interesting question. Are you looking?
Allowed, preemptive side deals.
Are you looking for communications in advance of the negotiation?
Yeah, so like if I want to get a hold of another party and work out a deal to stab another party in the back.
Wow.
Because you're looking to stab another party in the back.
Thank you.
Let me say this. In advance of the negotiation session, let's not complicate it, so no communications. During the negotiation session, I think everybody has everybody's email. If not, I will make sure to send it out to all the teams that you have everybody's emails. You know who everybody, I've already indicated who's on whose team. So during the negotiation session, if you want to fire off private communications, that's fine. Okay? We will try to reach an accord. I have made this, because of the confidential information, I've made this not impossible. It is possible, I think. But it will be challenging, especially in 90 minutes. I think it'll be tough. But I want to see how far you guys can get. The point of this is to see the differences in the interests and how politics play into this whole thing with stakeholders and who the stakeholders. And I've tried to limit a little bit who the stakeholders are. In the real world, there's many, many more stakeholders, especially domestically within each country. So, any other questions about the negotiation? session we're having coming up. All right, one other administrative issue. Those of you that are writing papers, I will be circulating soon your presentation dates. Remember, everybody's doing a presentation. Okay? That's going to, what's that?
I'll pick the final.
Present on a topic or
You're
just-
presenting on your paper topic, yes. Yep.
First draft of our paper's due Friday, right?
Yep. Yeah, for my students, first draft coming soon.
And if it's not
Right.
read writing, do we have to turn in a draft?
No, you don't have to. Okay? So everybody's presenting on their paper topic. I will send out the information. It's going to be 10-minute presentation, actually up to 15 minutes, but we want to leave time for Q&A. So everybody's doing a 10-minute presentation plus 5 minutes of Q&A. If you want to eat into your Q&A, I'd suggest not, but that's part of your prerogative. And as soon as I confirm the schedule with our professors on the 2 other campuses, I will send out the list.
And for those that are taking an exam,
That's separate. Yeah.
there's no presentation.
No, because it's all in your exam.
And you're gonna give some guidelines on what to expect?
On the
like-
exam, yes. Yep. All right. Okay. We ready to move on? Any other comments, questions?
Have you encountered a series of study or articles and presentations called The History of Water out of the University of Bergen in Norway?
No.
In that,
No, that does not.
The reason
Yeah.
I bring this up, one of the things they're doing is they're hauling out water in gigantic bags, towing it behind a barge,
Yep.
towboat, and selling it to various places, and they seem to be increasing. And I'm getting that series, but it's got a whole bunch of stuff in it, and I will,
Yeah.
when I get
The-
the CDs, I'll get them to you.
Yeah, sure.
So-
I'd be interested to see if they're actually doing the selling they're called Medusa bags.
Yeah.
Because I've
Yeah,
not
exactly.
seen it. Yeah, I've not seen anybody who actually has done this consistently, profitably. I know the inventor of the bag, and he's not been very successful.
Okay.
So I'd love to see what.
They didn't talk about successes, they were just showing, here's a guy pulling it out with his towboat.
Yeah.
And how
Yeah.
much it was in there, and that was their future. When oil and everything else plays out, the Norwegians will still have a source of power because of all of their water. So anyway, I'll get
Yeah.
that to you when I get them.
No, that'd be great. That'd be great. All right, ready to start groundwater? All right. So I'm going to give you a little bit of background about groundwater. As some of you may know, this has been one of my particular interest areas. Can you guys in College Station see the slides?
Yes, we can.
Yeah, I can't hear you. Is that yes?
Yes.
Thank you. Good. So this has been one of my research areas for many years, and so particularly strong interest for me in this area. And I'm going to be really interested to see what you guys come up with, because this is a really underdeveloped area of law internationally. All right, so globally, groundwater is really what many of us have called the hidden treasure. It's a hidden resource, the most extracted natural resource in the world, more than oil and gas, more than coal, more than anything else. I just put this number down because that's the number I found for 2015. I can't picture it. 982 cubic kilometers. So trying to picture a cube that's a kilometer on all sides, and which I'm not sure my brain can really do that, and 982 of those. I mean, almost 1,000 cubic kilometers. It's just a tremendous amount of water. As you can see, India in particular has expanded their groundwater use. But many countries have really expanded their groundwater use globally. And what we're finding out right now is that many of these aquifers that they're extracting from are transboundary. And I'll show you that part in a minute. But we know right now that groundwater, generally groundwater, whether it's transboundary or domestic, is providing almost half of humanity with just basic water needs. So drinking, hygiene, cooking, those kinds of things. And then you have some other statistics for groundwater use on a global basis. If we're looking at water globally in terms of the volumes we have, so this first slide shows wetlands, large lakes, reservoirs, and rivers. This is what we've been relying on for thousands and thousands of years. You know, all of humanity has been relying on surface water, with some exception where you do have water scarcity, like in the Middle East, arid regions. They did have some groundwater, but we really didn't develop groundwater until the 1940s, 1950s, when we started to develop mechanical pumping. So these are sort of the volumes of surface water in cubic kilometers that we know of globally. And that's not too hard to estimate because we can see it. We can see the rivers and lakes. That's water in ice. Okay, the Antarctic, massive amount of water in Antarctic, a lot of water also in Greenland. I don't see it in the North Pole. There is no land mass, so they don't include that, the ice flows up there. But you can see a lot more water frozen around the world. Take a look at this, groundwater. There is at least 100 times more groundwater, I should say available, accessible groundwater than surface water. There's actually even more than that that's not accessible because it's either frozen, such as in Siberia, parts of Greenland, Canada, so we don't count that. And there's even more groundwater that's so deep that we don't count it as accessible. So about 100 times more accessible groundwater than all the surface water in the world. Just a tremendous, tremendous amount of groundwater around the world. So one of the questions is, well, where is it? So this is the map of transboundary watersheds. Anybody know from the readings, remember how many transboundary rivers, lakes we have around the world? Anybody remember?
I saw so many numbers, I don't.
Okay. It really depends on how you count. 263, some say 273, some say 300. And the question is whether you count a tributary that crosses the border, and then the river, the main stem crosses the border again, whether the tributary is a separate river or not, depending how you count it, somewhere 260 to 300. How many treaties do we have for transboundary rivers and lakes around the world? Anybody remember the number? All right. Since the year 800 AD, and there's been a number of studies, but so for the last 1300 years, we have over 3,600 treaties. This next map is the latest map that's been developed for transboundary aquifers around the world. So the question, how many transboundary aquifers cross an international political boundary? We said there's about 260 to 300 rivers and lakes that are transboundary. We just started counting about 10 or 15 years ago, and it's over 600 right now. So more than double transboundary aquifers. So in other words, with the exception of most island nations, every country in the world is hydrologically connected to its neighbor. So there's going to be a transboundary aquifer somewhere. And if you look where the population centers are located, many of them are right on top of these transboundary aquifers. All right, transboundary rivers and lakes, 260 to 300. We have over 3,600 treaties. 600 plus transboundary aquifers and aquifer bodies, and we're still counting. This is we just started about 10 or 15 years ago. How many treaties? You can count it on your hand. One hand. Well, there's 2 treaties. Actually, only one of them is for the actual management, and that's over the Genovese aquifer. There's another treaty between Saudi Arabia and Jordan. They just entered into about 4 or 5 months ago. And that one is on where they're not going to withdraw. So it's actually a prohibition on withdrawal. U.S. and Mexico, we have an agreement to, again, prohibit withdrawal in the Sonora, Arizona region. I'm drawing a blank. I'm trying to think where else we have an agreement. We have 2 data sharing agreements in North Africa, and all they are to agree to share data.
There's a couple of conventions that mention it.
There's a couple of conventions. The UN Watercourses Convention references groundwater. Now that the convention is in force, arguably it applies to groundwater, and I'm going to challenge that in just a little bit. The European UNECE Water Convention, which is sort of the watercourse convention for Europe, it definitely references groundwater much more than the UN Watercourse Convention. But again, to what extent? That's part of the question. Much of this lack of treaties is directly related to how much we know or don't know, or I should say knew or didn't know about aquifers and groundwater. Up until the 40s, 50s, 60s, our knowledge of groundwater was a little bit limited. Certainly in terms of our ability today, where we have satellites that can take images with radar to try to get the contours, general geographic areas of groundwater, of aquifers. We know a lot more today. But the point is, we've got more than 2 times as many transboundary aquifers as we have transboundary rivers, and we have a fraction of a fraction of a fraction number of agreements on them. But again, if you didn't know there was a transboundary aquifer, why would you enter into an agreement? So it sort of makes sense. But this is, in my biased opinion, this is one of my research areas. This is going to be a growth area for countries to enter into agreements. I think they're going to have to. Just like I said, Saudi Arabia and Jordan just entered into one. There's a few others around the world that are now discussing behind closed doors the potential for agreements. Before I ask you questions about, well, what law applies, what is groundwater? Can anybody try to explain what is groundwater?
Aren't they still debating exactly what you consider groundwater? Whether you have whether the water in the unsaturated zone is considered groundwater, or if it's just the saturated zone in the aquifers?
That's one of the questions that they have been debating. You have water that is underground, and the question is all underground water groundwater? Is a legal definition. I think I mentioned that I worked with the UN International Law Commission to try to develop what they call draft articles or generic rules, and we'll come back to those next class. We spent 2 years trying to define the word groundwater from a legal point of view. We gave up. Why is it so hard to define groundwater from a legal point of view or even a policy point of view?
Because groundwater is connected to all parts of the water cycle. You have the base flow of rivers and streams. You have the saturated and unsaturated zones. So to try to legally make a boundary about
We can't hear.
Yeah, if you can speak into the microphone a little more.
I'm sorry. It's hard to define the boundaries of where groundwater starts and ends because it's connected to all parts of the water cycle. You have base flow of streams, and you have the saturated and unsaturated zones. So, like I know in Dr. Kaiser's water law class, they were talking about is the groundwater in a channeled, like, is it in a channeled flow, or does it have preferential flow underneath the surface water? Is it considered surface water or groundwater?
Okay, so think about it in terms of surface water. When we have international law for surface water, what are we actually having a law for? What are we regulating? What are we managing?
The pollution that goes into the surface water.
Okay, so we might control the pollution going into the water. Okay, what else?
Mostly the quantity.
I'm sorry?
The quantity of water. And
The
that's
quantity.
Why,
So
that's
we-
why in groundwater it's subject to a lot of variability. If you pick a certain geographical area and the availability of that groundwater could be subject to a lot of steps in the hydrologic cycle, which might affect.
Well, aren't rivers and lakes part of the hydrologic cycle?
Yeah. Of
So
course.
why can't, just like we carved out surface water and we're now trying to regulate it, why can't we carve out groundwater and try to regulate it?
First, you would have to know how much is there, right?
Okay?
I think we're
I mean,
still having
do
trouble.
we know how much water is in a river? I mean, we can do measurements.
Yeah.
No, we can do measurement. We put flow meters, right? How do we measure for groundwater? You're saying we can't? What's that?
Seismic?
What's that?
Would you use seismic to try to measure?
Seismic, radar. Do we have anybody that's taken like a hydrogeology class? How do you measure groundwater volume?
We use
It
monitoring
is
wells.
difficult.
We use
Okay,
monitoring
monitoring
wells.
wells? Yeah? What does that tell? What does monitoring wells tell you?
Depth,
Okay, so it gives you depth. It might give you, if you have 2 wells or 3 wells, you start to develop flow, right? You can tell maybe flow direction.
There are a lot of equations in hydrogeology that look at different monitor wells or piezometers, and they look at the movement and try to estimate how much water is there.
Yeah. So that's a great point. It's based on estimation.
I mean, these hydrogeologists need to pick up the speed. I mean, like, you have like 3D measurements of what's going on in there.
Well, and we do have 3D measurements. We do have things that we call conceptual models. They will literally build a conceptual model.
Sure, that sounds
We-
like.
Yeah, they
kinda
have
close,
mod
but not
flow,
really.
but I'm not sure how accurate mod flow is.
Yeah, yep, and that's one of the questions, one of the challenges. So you can see water in the river, you can put flow meters, and you can measure the volume in a river. It's still based on statistical analysis and estimations, but the numbers, the outcome of your analysis is probably pretty close or closer than it is for measuring the volume of an aquifer. A little more challenging. We don't see it. I mean, the whole point you don't see it. You can't see it. It's very hard to measure.
I mean, so there's no like seismic technology that they've developed? I mean,
Yes, they
if you
have.
send somebody to the moon, then
No.
you'll be able to measure what's here.
Well, and so we measure it indirectly. Think about the measuring water flow in a river. You can put flow meters. You're measuring it directly, right? As opposed to trying to, now you've got the wells, but that's only one point, one data point. Then you put another well. Oh, it's another data point. One other well, that's another data point. Pretty soon you can start to develop a three-dimensional conceptual models. The more data points you have, the better your model. Except that how many data points can you afford? Each well that you have to drill has a cost. And it's a lot more expensive than trying to put flow meters at different points on a river. Right?
I guess there is a special tool.
Can't hear you.
Yeah, sorry. Hello, can you hear me right now?
Yes.
I think the NASA especially have a grace called how to pronounce the word? GRA.
Yeah, GRACE.
Yes. Recovery and climate experiment. That's a model of NASA to especially use the tool to measure how much groundwater for the whole planet. So I guess that's a way
Right.
to measure the underground water.
Yeah. No, and those tools have been really helpful, more, especially recently, trying to measure the reduction of volume in California, for example, and the areas where groundwater has really been depleted over the last 5-10 years. But again, they're using either a radar or some kind of ground penetrating technology. They're measuring the waves as they bounce off of rocks versus bouncing off of liquid drops. And they can then get a geographic representation of the contours of the aquifer. And then they try to measure, based on how those waves are bouncing off, how dense that water is, if it's under pressure, and they can try to gauge the volume. Remember, that's still indirect.
Yeah,
You're not sticking your hand into that water, but they're starting to get better at it.
And I think there might be a lot of people in the general public, and I know I thought this for a long time, but some people think that groundwater is just like a big lake down there.
Yep.
But it's actually not like that, apparently.
No, it's not. It's not a big lake.
That was a rookie mistake.
Yeah. Well,
But I mean, that would make it a lot harder to quantify.
Yep.
If it's saturated.
Yeah, and in fact, if you study groundwater, there are a few cases where you do have water flowing through holes and channels and tunnels. And the best example here in Texas I can point you to is the Edwards Aquifer. It's a karst aquifer, meaning that the limestone gets dissolved in some portions, and you literally have tunnels where water is flowing through. Most aquifers are not made of that same material. Think of an aquarium full of sand. Okay? Any of you own fish tanks? You have fish? Okay. Fill it all the way to the top with sand, right? Is it completely full? If you put water into it, the water flows in between all the grains of sand, right? So it's starting to fill up. And if you look at the side of the aquarium, you'll actually be able to see the water rise up. This is what's called an unconfined aquifer. You can see the water table. That's the top of the water. You have a saturated area. Remember, you just poured water all over the sand, but the water only went halfway. The sand on top is wet, but it's not saturated. So you have saturated area and an unsaturated area. And this is the part that we just questioned about, what is groundwater? Is it the wet part, which is everything, or is it just the saturated part? Technology, we can actually get water out of the wet part, the unsaturated. It's really hard, it's really expensive, it's completely uneconomical. But in a place where you don't have water, that might be the only, still a good source of water, who knows? Usually when we extract groundwater, it's from a saturated formation where you have good flow and transmissivity, meaning the water actually can flow in between the grains of sand. So for example, if you have a shale formation, that's a layered formation. It might be wet, it might be saturated, but you can't extract water from a shale formation because all those layers don't allow water to flow in between each layer. You guys have heard of fracking? Fracking is drilling into a shale formation full of gas or oil. And fracking, you're fracturing that rock and making holes in between all the layers and allowing the oil and gas So we could frack a shale aquifer. We could do it and get water out of it. Now, is it economical? What's the price of a barrel of oil versus the price of a barrel of water today? Yeah, so it's not economical for water, at least because we don't value water the same way we do hydrocarbons. So this is something you have to think about. If we're going to regulate groundwater at an international level, you have to think about, well, what is groundwater? So I have just a sort of a brief definition. It's not a legal definition. And as I told you, when I worked with the UN on this, we gave up trying to come up with a legal definition. If you're interested, I'm not going to go to this YouTube. These slides are already posted on our website, but you can see this YouTube, and it kind of gives you a better sense of what groundwater may be and how it flows. So in international law, we talk about water in a river or lake. We also talk about a water course. All right? I'm not sure this is the sort of the right equivalent, but in groundwater we talk about an aquifer. So what exactly is an aquifer? Water course, we tend to think about the container of the river, the lake. An aquifer, is it the container? That's sort of how you might think about it. The formation that is able to hold that water to allow it to flow through that formation, right? Again, a non-legal definition, permeable formation, that it can store water, but it also can transmit water. So shale can store some water, but it really can't transmit water. Sand can store a lot of water, and it can actually transmit because the water can flow through the grain of sand. And then this is the problem that we really had when we were talking to lawyers. Provide a useful water supply. Come on, lawyers. What's the problem with that language?
Useful? There's open store for everything.
Yeah. What's useful? And remember, we talked about fracking technology. We didn't have fracking technology, 50 years ago for oil and gas. We didn't use it until about 10 years ago. We now have it. We can frack an aquifer now. So does that mean a formation that is a shale formation that is saturated with water, but we can't pump it? But now we can frack it. Does that mean it's now legally an aquifer? Whereas yesterday it wasn't an aquifer legally. Are there other formations that today cannot provide water because we don't have the technology, but they're saturated? And as a result, are they not aquifers? So this is a huge issue that we try to deal with from a legal point of view, and I don't think we did a very good job on the international level, which is one reason why we still don't have a lot of support for the draft articles that we developed, and we'll talk about that next class. Again, if you want to see some videos on what an aquifer looks like, I'll leave that to you later. Some other concepts I want to just throw out. Some other concepts just to think about. Unconfined aquifers, that's like your fish tank sand. You have an impermeable layer below, that's the bottom of the aquifer. Nothing impermeable above, so water rains, rain falls, it flows into the aquifer. Confined aquifers have a confining layer on top and on below. There's got to be some place where it's unconfined, because it has to, reach the aquifer. But it's confined, so you have to break through that confining unit. Recharging versus non-recharging aquifers. The first one is connected to the hydrocycle. The second one it's not connected to the hydrocycle, meaning you pump it, it's going to go dry eventually. Now, you mentioned the hydrologic cycle. Is the aquifer feeding a river? Is the river feeding an aquifer? Those are questions I want to just throw out, because how do we regulate these aquifers? And just some diagrams. You can see here, here's an unconfined aquifer, because there's nothing confining it above. Any rain that falls on the surface, it can infiltrate and fill up the aquifer here. Here's a confining unit. Underneath it, there's a confined aquifer, meaning that the water entered this confined unit somewhere off the slide that we can't see, where it's unconfined. There was a recharge area. Now you can see some of these blue lines cross through the confining beds, the confining units. Well, that's because nothing's absolute. Even an unconfined unit is not absolute. And occasionally you can get leakage that's flowing through those confining units. And the question here is going to be, well, do you regulate unconfined aquifers differently from confined aquifers? Here's the aquifer feeding a stream. That's the top one, the effluent stream. The bottom picture, that's the stream feeding an aquifer. It just depends on how full that aquifer is underneath the river. If it's really full and it flows over the top, well, it's going to feed the river or the stream. If it's not completely full and gravity is going to pull water from the river into the aquifer and feed that. So you have a hydrologic relationship. Do you regulate these any differently? Now let's throw the international boundary. My question to you, all these little bits of information I threw out, what are the issues that you can think about, or we should think about on the international level? Two countries, and we'll start with only two countries, sharing an aquifer. What are some of these legal issues and the implications?
One country using more than they should?
Well, what is more than they should? How do you gauge that?
One country using it so much that the other country who overlies the aquifer can't also use that?
Okay. Think about your aquarium. Put a pump in the sand and start pumping water out. What's going to happen?
Yeah, put the well deeper, deeper.
You're going to have to sink the well deeper and deeper if the water table is dropping, right? Good. Now, one thing we have to realize that the flow of water through the gravel, through the sand, it's not as fast as on the surface. So the impact it might have a mile or two away is going to be delayed. Does that make sense? It's not like...
So it's hard to assign liability if you can't tell the approximate cause of who caused that harm.
Who reduced the water on that other side? Which well is the culprit? Yeah.
I remember.
Okay.
Multiple ones.
What else?
The same is with the pollution. Who's polluting?
Just like water is flowing slowly through the aquifer, pollution is going to flow slowly through the aquifer. Yeah. Where did the pollution come from? Let me build on this question. Remember significant harm for surface water? If you have pollution stored, some kind of pollutant stored on the edge of a river, do you have significant harm transboundary? It's stored, it's in a container. Is there significant harm?
Significant harm only after the fact.
Well, only after it spills, all right? At what point does significant harm starts to occur? Is it when that container breaks and water starts to flow into the river? It's still within the country. Or at the point it enters the river? Or at the point it crosses the border? At what point let's not say significant, at what point would you have harm? Transboundary.
When you can prove causation.
Yep.
Well, you can see the container It ruptured, you can see the leak, it's going into the river. At what point would you assign harm? When it enters the river, when it crosses the border, when?
But the harm to the water course happens when it enters the water course, but as far as the country is when it crosses the border
Yeah.
of that particular region.
All right, now, think about legal harm. Those of you law students here, think about what's actionable. Is it actionable to have harm to the river in and of itself as opposed to harm to people?
I guess it depends where you are.
Yep.
Okay. Think about the Clean Water Act. For those of you that have studied the Clean Water Act, water pollution law. We have statutes that say don't put pollution in the river. Why?
Because it affects the public health,
What's that?
affects the public health.
Affects public health. What?
Harmful to the environment.
Clean Water Act. Ah.
They can like directly prove that it was like from a non-point source that comes directly into.
Right, but what's the purpose of, what is the Clean Water Act trying to protect?
Fishable and swimmable waters.
Fishable and swimmable, so who are we trying to protect?
The environment and the people.
Is it the environment?
People.
It's people. It's the value of clean water for people.
So we're consuming it.
Yeah, it's fishable, meaning that there has to be fish there for people to enjoy, not for fish there for the fish to enjoy.
Probably wouldn't enjoy it without it.
Okay? Well, you would enjoy having fish in the river even if you don't fish, but that's a value to people. So any harm, legal harm, is harm to people. And if you look at the Clean Water Act, if you look at the Safe Drinking Water Act, arguably even the Endangered Species Act, it's harm to people and how they value endangered species. The Endangered Species Act is the closest statute I can think of where it's really harm to the species, but it's only because we as a society decided that there's a value that would be harmed if those species became extinct. We don't protect the environment for the sake of the environment. Now, on an international level, what you were suggesting is the harm occurs not when the pollution comes into the river, but when it hits the border, right? How about pollution of an aquifer? The spill is soaking into the ground. Have we caused harm yet? The spill is now infiltrating the aquifer in our country. Has it caused harm yet?
Not till it's been consumed.
Not till.
Not till it's been consumed.
Okay. Well, by the other side, so does harm occur only when the spill crossed the border, just like in the surface example? We can use the same, and this is going to be the question: do we apply the same law for surface water to groundwater? Do we want to say the same rule? Harm occurs at the border.
No, because in the readings we had, like in the paper you had all these 6 different types of aquifers and how the laws should apply different. Some of them are not even considered a water source as the UN convention.
Okay.
So it shouldn't apply the same way. I mean, the basic general rules maybe, but they will have to be more specific for them.
Okay. Why would we want more specific rules for groundwater? Think about the crash course in groundwater that we talked about a few minutes ago.
It's more unknown.
What's unknown?
The content, where it is, how much, all about it, really.
All right. How about trying to clean up an aquifer? How do you clean up a river? What's that? The river?
cleans by
Okay.
itself most
It-
of the time.
It's really, it sort of filters itself as you get water flowing through the river.
Never mind.
Do you remember the example I gave on the Teesa River? And they, where you had the cyanide spill, and it took about a month for the water to get downstream to the end of the Danube River. Okay, but it did flow through, right? And eventually the water, it cleaned up, except for the heavy metals that ended up in the bed of the river. So we had contamination of the bed, but the water cleaned up. How about an aquifer?
Lower, and sometimes it doesn't happen if it is a fossil aquifer, how they call it,
Yep.
that it's stagnant.
Yep. If it's a fossil aquifer, you don't have any flow in that aquifer. So you put pollution in it. The pollution may not spread very much because there's no or little flow, but the pollution is going to go to at least a part of that aquifer. And how do you clean?
No, they imply they don't use those fossil aquifers as much as the other ones.
Who implied that?
Or using, well, in the readings you kind of get where those have been there for thousands of years.
Yeah.
And apparently, they didn't say it, but I got from the readings, like, they like those aquifers where the water is flowing more than those that are.
Sure, we prefer those, but think of the U.S.-Mexico border. Think of North Africa. If you look at the map of North Africa and where all these transboundary aquifers are located, the Nubian sandstone, the Western Sahara aquifer, there's a couple others. They're all fossil aquifers. Water that was deposited 10,000, 20, 30,000 years ago. There's very little connection to the hydrologic cycle, meaning rainfall in that region rarely actually infiltrates the ground and gets and replenishes the aquifer. It just doesn't, it evaporates too quickly.
It's a finite source.
It's a finite source.
Finite.
And, yeah, but it's, what else, what other source of water do they have? So it really depends where you are, whether you use a fossil aquifer. By the way, the Ogallala Aquifer underneath Texas, New Mexico, Nebraska, all the way up to South Dakota, one of the largest aquifers in the world. Many people call it a fossil aquifer because it takes about 10,000 years to recycle, replenish. It's a slow-moving aquifer, and there are some locations where it is getting some recharge, but it's not the entire aquifer. And on the high plains, Lubbock, Amarillo, they grow 20 to 25% of the cotton of the United States. They're using groundwater out of the Ogallala, and they're draining it. That's the only water source they have. So do you regulate a fossil aquifer any differently? Do you regulate pollution for groundwater versus pollution for surface water any differently? What else? What other questions could you throw out in terms of regulating?
Are there any examples of them regulating those two types of aquifers different in the United States? Or is that just a state by state?
Groundwater law is state by state in the United States. And I don't know of any, well, there are some states who do have special zones for some aquifers, just like the Edwards. We've designated as a special zone, the Edwards Aquifer Authority.
Yeah, just like the Ogallala covers practically the entire states or a lot of the states.
Well, good portions of them, and so, but we don't have agreements with our neighboring states over managing the transboundary aquifers in the U.S.
Gotta get over our states' rights thing.
It's, the first case, there's been about 50 cases that went up to the U.S. Supreme Court on transboundary rivers and lakes in the U.S. The first case over transboundary aquifers just made it to the Supreme Court. We're now waiting to see if the court fully accepts it. It looks like they're gonna process it. Mississippi sued Tennessee.
Memphis?
Yeah, Memphis specifically, but they had to sue Tennessee because it's a original jurisdiction issue. It's a state versus state. So that one is now being reviewed by a special master, I believe. Actually, I don't know. I don't know if they've gotten a special master. I think they're still reviewing whether they're going to They're still briefing the case in front of the Supreme Court. So, yeah, so we don't have a lot of experience with this stuff. We don't know if we need to regulate fossil aquifers differently from recharging aquifers or confined aquifers from unconfined aquifers. So going further in the questions, so I just threw up some questions. How do you manage or allocate something you can't see? That's the first thing. Okay, we have the GRACE satellite, we have radar, we've got well drilling and conceptual models, but that's still something a little bit different than rivers and lakes. What law do you apply to transboundary? I mean, are you going to apply the same law that you apply to surface water? Let me stop there. Can we go with equitable and reasonable utilization, no significant harm, data sharing, monitoring, prior notification? What do you think?
With aquifers, it would be a
Name
little
good.
bit different depending on what kind of aquifer you were dealing with. So if you had a fossil aquifer or one that had very slow recharge, you can't, the allocation would have to be a little bit different because you're working with something that is not being replenished, whereas rivers essentially are replenished every year. So you could have an annual withdrawal limit or allocation, whereas groundwater, it's a little bit different because we're
So-
not able to predict how much, unless we say there's a steady state and it's fixed, you have a fixed recharge amount every year, and as long as you don't withdraw more than that recharge amount, then you're in a safe zone. But with a lot of the aquifers that people use, there is no recharge, or it's very little recharge, or they don't really know how much recharge there is.
Would you regulate the aquifers that don't have any recharge the same way? Would you restrict extraction? What would you do with fossil aquifers?
At the very least, there should be monitoring, though. There should be regulated monitoring, as with the Safe Drinking Water Act and the Clean Water Act. I mean, that's the very least that should be done with the aquifer.
Okay. If I asked you guys to draft laws right now, what laws, what rules would you draft? We got monitoring laws. What else?
I think the principles are good. Those principles could be used. It's just different variations of them. You know, different application, but the same principles.
Okay. Do you think the no significant harm would work the same way?
It depends
I
the
think
type
with an
of-
aquifer, maybe like precautionary measure law would kind of apply, since we're not exactly sure what is in the aquifer. So some type of like precautionary law rather than.
Okay, some precautionary approach. We don't seem to like the precautionary principle in the United States very much. Europe.
Yeah, that's true.
Europe tends to like it much more. Other countries, but in U.S. we don't seem to. We seem to go with the safe until proven harmful approach. What else?
I know Texas.
Would equitable and reasonable work? What would you need for it?
To know how much is there.
Okay, so you need to know how much is there. What else?
You would need to know the flow of the groundwater.
Okay, flow direction.
Define what equitable and reasonable is. in that
Okay.
sense.
Okay, trying to define equitable and reasonable. I mean, we tried to do it for surface water.
Again, the same thing.
Is it the same thing? Are we trying to allocate benefits and regulate reasonableness, reasonable use, which is what we're sort of trying to do for surface water? if I'm asking you to negotiate this right now, you've got to come up with rules for a transboundary aquifer. What rules? I mean, I've heard monitoring. I've heard maybe significant harm, but maybe a little bit different. I gave you the example of how that slow pollution coming into the aquifer, right? So,
The
Ash,
uses.
what's that?
The uses
Regulate the uses?
and the amount of people, we need to know the population or the amount that they're gonna be using from that river and for what,
Okay.
from that river, from that aquifer and for what.
Okay.
Do you need to know how much of the aquifer is below each of the territories?
Does it matter how much of the portion of the aquifer is underneath
That's
each?
something they had talked about, and the text was sovereignty over, the portion that was below your country.
Yeah, how about this
DRC
sovereignty thing?
regulating the capture.
Can't hear. Thought I heard somebody speaking. College Station? No?
I know I've been reading some papers on international groundwater law, and one author addressed, so you were talking about significant harm. One way that you could harm groundwater where you wouldn't be able, or where harm is not addressed in surface water is harming the potential storage. So if you over withdraw from an aquifer, you could get some sort of subsidence, which would then reduce the potential storage for that aquifer in the future, especially if you look at technologies like aquifer storage and recovery or artificial recharge.
So think about that. It's a really interesting point. If you drain a river, what happens to the riverbed? Not much. Okay, it just sits there, right? When you drain an aquifer, you're removing water from all the spaces between the sand and the gravel and all the other material that's underneath there, and you're allowing. Remember, this is under thousands and thousands of pounds of weight.
Those are the sinkholes in Florida.
You get the sinkholes in Florida, exactly, and you have those in the Houston area, and now in Texas we have these subsidence districts now, absolutely, because they compact, and they once they compact, they destroy the formation's ability to store water. So do we need to regulate the formation itself, the container?
Then you can only authorize certain amount of water to be withdrawn or at a certain rate.
Okay.
So it kind of matches the recharge in a way.
But what about fossil aquifers if we don't have recharge?
Is that part of the mineral estate?
What's that?
Is that part of the mineral estate?
Is
How do
it-
you regulate that?
Is groundwater part of the mineral estate? That's a great question. How about from oil and gas? Those of you who've taken oil and gas, where's groundwater?
It's within,
No.
or is there?
Groundwater is part of the surface estate.
If it's within so many feet.
Groundwater is considered part of the surface estate regardless of the depth, meaning that groundwater in Texas and most of the U.S. is not a mineral. It's not considered like oil and gas in terms of mineral rights. Okay, you can, if you sever the mineral estate, groundwater stays with the surface estate. Okay, but in Texas, because we are so focused on oil and gas, we had the Day case about 3 years ago, and the court in the Day case said that we're going to regulate groundwater more like oil and gas, although we won't call it a mineral estate. We won't call it groundwater mineral. We're going to regulate it, at least just in Texas, more like oil and gas. And that's where we have this rule of capture and ownership in place. You own the land, you own the groundwater underneath. Texas is a bit of an outlier on that part. But it does create problems with aquifers that cross the border between Texas and New Mexico, Texas and Oklahoma, and so on. Because in Texas, private landowners have private property rights across the border in all the states surrounding Texas, groundwater is a state resource. So it can create challenges when you have different domestic laws. So just a couple more questions for groundwater. Okay, so what law do we apply? Do we apply the same as for surface water? If we do, does it have to be modified in some way? So the significant harm example, I asked the question, where does harm occur? Well, on a river, once it hits the border. In an aquifer, it's unclear because it's so hard to clean an aquifer. So maybe once the pollution hits the aquifer, or but we don't know enough information, we don't know which way it's flowing, so maybe once we know it's starting to flow in the direction of the border, when does harm occur to the other state? Even though it's unclear. We have no precedence, we have no idea where to go with this. So this is still an open question. Equitable and reasonable utilization. We're going to need different types of facts than we do for surface water in terms of how much water, where the water is, and so on. That's the generic, okay, that's the same, but groundwater information is much harder to come by. Data sharing, monitoring, it's a lot more challenging to do that. So you have to tailor some of these rules that that we've tried to apply for surface water to try to tailor or adapt them to groundwater. Should groundwater be treated like subsurface natural resources like we do in Texas? And land ownership, groundwater ownership. Well, should we do the same? That's a sovereignty issue. If we share an aquifer with Mexico, do we own the water up to the border? Well, go ahead.
That doesn't always work with an aquifer because some aquifers wouldn't be there for the recharge point. And the recharge point could happen in another state. And
Yeah. Well, think about it. We have the Rio Grande, right? Originates in Colorado, gathers more water in New Mexico, and then we completely drain it before it hits the border with Mexico. And then there's more water comes in from the Pecos and the Rio Conchos, but then we drain it further down the Rio Grande Valley. How about an aquifer? It might have a recharge in one country. Well, why don't we just do the same thing with the Rio? The Rio Grande is subject to international water law. We've decided in a treaty how to apply that specifically here. You can argue it's equitable and reasonable, and there's no significant harm component to it. Could we do the same thing with groundwater? It's a little more complicated. I think most of these questions kind of ask, except the last one, which relates to what Awilda you just said about the recharge zone. What if the recharge zone is in one country and the storage is in the other country? So the country where you have the recharge zone, they can't benefit from the water unless they try to prevent it from entering the recharge area.
but they're the ones that, because of them, they have that water in the aquifer.
But so the other country
location.
that has the storage, they're benefiting because they can put wells into the storage, but they don't control the recharge. And there's a number of examples of this around the world. The best example of this last scenario is what's called the mountain aquifer, where you have most of the recharge between Palestine and Israel. Most of the recharge of the mountain aquifer is in the highlands, which is the West Bank, which is sort of where the Palestinians are settled to some extent. You have in different cities, the refugee camps, and so on. If that's going to be the future state of Palestine, that's about 90-some% of the recharge area. As far as storage, 90+%, 95% of the storage is under Israel proper. So the Palestinians can't enjoy fully. Now, I'm putting aside the politics and the control issue, but if this was sort of a harmonious scenario, the Palestinians can't fully enjoy the storage because it's not underneath that territory. How do we, where's the incentives for the Palestinians to protect the recharge zone? It's a very serious challenge. Let me add one more thing to it. You mentioned uses, regulating uses. Anybody ever drive around the recharge zone of the Edwards Aquifer? Come on, those of you driving around Austin and you see those signs, what do the signs say?
Don't breathe.
What's that? Entering the recharge zone, and what else do they say?
Sensitive.
They might say sensitive. They're going to say no dumping. They're going to.
Never seen that.
There's
Breathe, don't litter.
I drive like this, I guess.
yeah, yeah. And the fines are very steep. It's not like just littering on the no littering signs, $50 that you see on the roads. They're much heavier in
Wow,
the.
how quick it recharges too, because you can see it in the Barton Springs.
Yeah.
Like a couple days after a big rain.
And that's that's because it's a karst aquifer. It's a very fast-moving aquifer, and so they really try to control activities in the recharge area. How much construction do you see in the recharge zone of the Edwards?
I mean, what's already completed, really, it's because like West Austin down there.
Yeah, I mean, they're really trying to restrict any kind of construction, any kind of industrial activity, any activity in the recharge area because they're trying to protect.
And I think Austin changed it so that when you do develop, you have to put something different on the blacktop surfaces.
To allow infiltration or to channel it into an area where it can infiltrate? Yeah. Yeah. Do we do the same thing about activities around a river?
No.
Certainly not under international law. Domestic law, we have the don't pollute statutes, right? The Clean Water Act. But it's a little bit different.
People view rivers or like under bridges, so you find all kinds of things,
Yeah.
like refrigerators, microwaves.
Yeah, so there's a lot of challenges in trying to regulate groundwater resources. I'll give you a little bit into what I was working on when I was what we had to deal with. So we spent 2 years trying to define the word groundwater, and we gave up because as a legal matter, we had a really hard time. I still think it was a mistake to give up. We ended up defining an aquifer for purposes of international law. I think that was an incomplete assessment in terms of coming up with rules and regulations that we were proposing at the UN level. We had politicians and lawyers. We had all sorts of folks trying to develop rules and regulations that might apply, very generic ones, like equitable and reasonable. And we'll talk more about them next week. They've been sitting in front of the UN General Assembly since 2008, December of 2008. And they keep getting tabled, which I guess is good. They're not completely throwing them out, but they keep reviewing them and then tabling them for another 2 or 3 years.
So if they did go in front of them, I guess they get enacted or whatever, then they just become recommendations?
Well, the question is, what do they do with them? One of the questions is, should they be enacted as a new treaty that countries should sign? And if you get enough signatures, then it becomes sort of law, at least for those countries that signed. Should they be guidelines? Look at the experience we have with transboundary rivers and lakes. 3,600 treaties, 3,600 examples of cooperation. Then there's all these other examples where it's not a treaty, but they cooperated. They have a project together, and that's over the last 1,200 years. Okay, a lot of them are about navigation, but over the last 150 years, we've had 400 treaties over transboundary rivers and lakes for non-navigational uses. So we have a lot of examples, 400 on non-navigational, meaning irrigation, water sharing, water allocation, all those kinds of things. Dam constructions, flood management, all that. We've got one water allocation, water management treaty in the whole world, Switzerland and France over the Genovese aquifer. We have two that basically what they say is we're going to restrict groundwater pumping in this region. It doesn't say how, what you really can do and where. It just says in this region, no pumping, or we're limiting pumping. This is between Saudi Arabia and Jordan, and between the U.S. and Mexico in the Sonora, Arizona area. We have two data sharing agreements in North Africa on the Nubian sandstone aquifer, which is Egypt, Chad, Sudan, and Libya. And then another one on the northwestern Sahara aquifer, which is, if I remember correctly, I think it's Libya, Tunisia, and Morocco, I believe. That's data sharing, not allocation, not management, just exchanging information. That's all we have as far as hardcore rules. We've got some less formal. We've got a treaty that they tried to enact on the Guarani aquifer in South America. Uruguay, Paraguay, Argentina, and Chile. No, Brazil, Argentina and Brazil, not Chile. They still haven't ratified it. So it's kind of sitting there, but they haven't done anything with it. There's one on the Ulamaden aquifer in Western Africa. It's an MOU. And for law students, you know the value of an MOU versus a treaty versus a contract. It's sort of like a good intention arrangement, but this doesn't have a lot of legal weight. We have handshake agreements between the water utility of El Paso and the water utility of Ciudad Juarez over groundwater. Again, not legally enforceable. We have the same thing on an aquifer between Canada and U.S., Washington State, and British Columbia. I'm really struggling. I can't think of any other ones. So 400 transboundary rivers and lakes for allocation and management, non-navigational, another 3,200 for navigation, and I just listed all the groundwater ones I can think of. That's, maybe I got to my second hand. I don't know if I got 6, 7.
Why is that? I mean, how long have humans been using groundwater on a large scale?
Well, since the 50s, 1950s.
You think it's
When we started getting pumping technology, gas-powered pumps, electric-powered pumps. It was World War II is when we developed the technology.
So you think that's why there's less? Because it's more of a recent development in comparison to
Sure.
when using the rivers in the Bible times?
Absolutely. I mean, we've been using groundwater in the Middle East since 2,000, 3,000, 4,000 years ago, but there's not a lot of experience internationally. It's usually just that locally, domestically within countries. Very, very few examples internationally. So one is we haven't been doing a lot of drilling using groundwater, and now that we have drilling technology, usually when you dig a well, you're going 30, 40, 50 feet by hand, maybe 100 feet, right? Otherwise, it gets really, it's hard to drill, to dig by hand. Drilling technology, 1950s, now we can drill a mile, 2 miles. If it's economical, we can go even deeper, actually. For oil and gas, we're going 3 and 4 miles or more. So now we're starting to use groundwater. Up until the 50s, very little groundwater we used. Today, it's, like I said, more than, or around half of humanity get fresh water, drinking, hygiene, cooking from groundwater. So we've really ramped it up in the last 20, 30 years, 40 years. Now we're realizing most of these aquifers are transboundary. Big gap in the law. If you guys are looking for jobs, this is, I think, one of the growth areas, trying to figure this out. Any comments or questions?
Does the 600 plus aquifers includes those that are partially under seabed or on a seabed or?
That's a really interesting idea because we didn't know about submarine aquifers until about a year or two ago. There was an article in Nature magazine that just came out a couple of years ago that said there are these somewhat fresh aquifers, they're a little saline, that are underneath the continental shelf, and we're not sure some of them how far they extend. They just started mapping these. And there's a question, one of my friends is now doing a PhD thesis on what law should apply. Is it law of the sea? Is it international water law? The very little international groundwater law that's been developed or evolved? That's going to be a really interesting one. Apparently it's a large volume of water.
Yes, that's
So.
what I read. And I was thinking that the desalination process, if they use that water, which is already only a third
Saline is seawater.
should be easier or better for that type of technology.
Sure.
But of course, they need to get it.
They need to get it so it's
Yeah.
under the sea and it's so far away from land, so you have to then transport it back to land. So you have energy costs. Yeah. Yeah. No, that's going to be another one that's just starting to develop, and there's virtually nothing written on submarine aquifers. Anything else? All right, we'll do one more class session on groundwater. All right, we'll see you next week. Thanks, guys.
That's yours.